in your experience, in your view, what was Stockton Rush's vision?
Stockton, he wanted to do a couple of things. He wanted to explore. He was an interested explorer at heart. Second thing he wanted to do was he wanted to bring down the cost of submersibles and exploring the ocean. It is extremely expensive. It's an unforgiving environment, and unforgiving environments require a lot of assets. And it's close. I mean, it's much different than sending a vehicle into space. That's not close. So, we can kind of expect it might be a little expensive. But let's face it, anybody who's facing the ocean, it's right there. And we don't know much about it. So he wanted to go explore it. He wanted to bring down the cost. He wanted to do something different. And he wanted to make a name for himself.
You can say a lot of things about someone who's no longer here in hindsight. To those people who say this was a man who had a death wish, he wanted to go out with a bang. I mean, were those his intentions?
It's a really good question, because I've asked myself the same while I was working with him. It was unclear sometimes what his objective was personally. If he really wanted to go out with a bang, I mean, there's some decisions that Stockton would make that made me wonder, like, this doesn't make any sense, really, not in a technical sense. So what's he trying to achieve here? And myself and my crew had the discussions, like, does he really want to do this? But we thought it can't be suicidal. I mean, that's really what it would be. I mean, if we're talking about he's going out with a bang and he's going to take somebody with him, is that really him? And it was difficult to draw that connection. And I think I testified that sometimes I often wondered just in his actions if he was borderline a psychopath, because of how different some of the days were and the decisions that he made. If it doesn't make technical sense and you're an engineer, you got to think, or you got to wonder, what are you thinking? If his intentions started out, it was a long program for him, and if it started out differently and it morphed into something else, like we even went kind of extreme in thinking what could be wrong here. Was he sick? Was he terminally ill or something? I didn't know it, but then we thought it would be stupid to take people with you if that was your intention.
You testified that Stockton Rush was a borderline psychopath. I
wondered. He was all over the place. Like, as erratic as he was in the way that he treated people, it made me wonder, like, this is inconsistent. He would literally yell at me quite a bit. And it didn't seem like it warranted that, but he was just pinging off the walls, trying to appease whoever he could, and not making sometimes a lot of sense. But yet you would see inside him that he cared about what he was doing, and he really truly believed in what he was doing. So much so that maybe steamrolling was his answer. It really came to head. I think I testified. He told me once that it would be nothing for him to spend $50,000 to ruin somebody's life if that person got in their way. I can't think of another word to describe a person like that.
You built the first Titan hull from carbon fiber and titanium.
Yep.
Was that a success?
The program was a success, 100%. And I'm glad you asked, because in order to ask me, was it successful, even though it never took paying passengers to the Titanic. In engineering sense, what is a success? And what do you build to? So for folks that maybe aren't engineers and do this every day, what do we get up in the morning and think we're going to accomplish? You're meeting a set of requirements. And you're meeting a set of requirements that somebody, maybe not you, set. So if I have 10 requirements that a vehicle has to meet, and I can meet all those requirements, that is a successful program. And whether or not it's used correctly, whether or not it's never used for its intended purpose. I think a really good one, a good example is of that is the Spruce Goose, an airplane that never was put into commission to do its purpose. And we have a bunch of those in history, but you can't call them failures. You also can't call them failures just because a sister of one that's built doesn't work. You can't call it a failure because something went wrong with it. Serial number 1, in particular, was hit by a lightning strike. There wasn't a requirement to really protect and shield ungrounded against a lightning strike. So I can't say that we needed to deliver on that, and really couldn't. So that's not part of the successful program. The requirements that were set forth that Stockton and the board wanted me to build and commission, it's a carbon fiber submersible that held 5 people and went to 4,000 meters and had a monitoring system, a health type monitoring system that would let you know when the hull is compromised and prevent a catastrophic failure. And that has come to be known as the acoustic monitoring system that we installed.
To those who say carbon fiber is not an appropriate material for a hull to dive to 4,000 meters, what do you say?
I would, in an unprofessional sense, I would say they don't know what they're talking about. If that's all they say, if they bring some data and some analysis, and they bring some piece of paper that says, hey, look, this won't make it. Sure, maybe that design for that material won't make it. You can take plain carbon steel and just to bring it maybe in simple terms, a bridge. A bridge is usually made of steel. You can make a bridge of steel not hold the cars that are supposed to go across it. But it doesn't mean that the steel is a bad material for it. Carbon fiber is great intention, and we know that. And that's become kind of synonymous with the material itself. And so the analog to that is, how does it do in compression? Most folks say it's terrible in compression. And it's true if you have a fiber and you push against it, much like you would push against a string, it doesn't hold as much as it would in tension. It is much better in tension. But if you come with the statement that carbon fiber is not an appropriate material for deep sea vessels or high pressure compression in a cylinder, so to speak, you would have to come and say that this layup type, this fiber, this glue type, and this shape, and this thickness can't withstand that load. Saying something like that is meaningful for the material, because the material itself isn't what determines all the time. It's not what determines whether or not a structure passes or fails or is appropriate or meaningful. Not solely the material. A lot has to do what you do with it. An analogy or an extension to that is, let's suppose that I made, and I believe I gave this example to the Coast Guard. Let's suppose that you made a block out of carbon fiber, and you made this block with a type of layup in a vacuum procedure. And so for folks that maybe don't understand what that really means, is that if you could take a look at a bed sheet, and it's just a thin sheet of cotton, and let's suppose that you stacked a bunch of sheets on top of each other, and you put glue in between them, and then you squashed it, and all the air bubbles went out. And then you vacuumed it, and you let it cure, and there's no voids inside, and a void is just a pocket of air. So you've achieved something called good paction in a carbon fiber structure. if you have good paction, and so it's a very solid piece of brick, of carbon fiber brick, and I put that piece under a heavy load, a big truck, a building, would it break? There's a possibility that it wouldn't. Now, what if I didn't process that so well, and there was a lot of voids in there? Then the compression would compress the voids, and the voids in that movement might break neighboring fibers and glue. But that doesn't mean that the carbon fiber was the problem.
When you've got a lot of mights and possibles, and you're talking about something that's carrying humans, isn't that taking a gamble with life?
That's kind of a loaded question, especially in light of the recent Boeing 787 plane crash. Like, on the order of 240 people lost their life the other week. Every time you get into an airplane, there's a gamble. To an extent, there's a gamble for sure. But it doesn't mean that the aluminum that's used in that airplane is an inappropriate material for it. It is a compromise. Airplanes are great. Airplanes and sailboats are like the great compromises of everything. Aluminum might not be the best material for it, but to carry the number of passengers, to get the range, and carry the payload, you need a thin structure, and you need a lightweight structure, and you need a non-corrosive structure. So you really cannot draw the conclusion that because there's a possibility that, well, actually, we'll say carbon fiber material fibers pushed in a particular direction are weaker in compression than tension, that putting humans or subjecting humans to depend on that material maybe not appropriate. That's more of a design question. Like, what did you do with it?
So was Stockton Rush and Oceangate aware then that anyone who got in that sub could die?
Stockton, I believe in his waiver, put it's an experimental unit on the first one, and I think that carried over to the second hull. Mentions the possibility of death, and that it was an experimental unit.
The first hull got a crack and needed to be rebuilt. So your view is that doesn't make the first hull a failure because the mission of it was to build a submersible that could go to that depth and do something that no other company had ever done?
That's correct. So the requirements, part of the requirements were put a monitoring system on board such that it will let us know early detection that that the structure was compromised, and we should not utilize it anymore to whatever depth we were going to go to. That's exactly what happened. So serial number one, the first hull, which is the one that I built, did suffer a lightning event close enough that it completely blew out all the electronics. And what you can't know is, did that lightning event cause the crack to form? That we can't know. It is highly likely that it compromised the hull because of the extent of damage to all the electronics inside the submersible, and the damage of the catamaran that was sitting next to it or close by during that lightning storm one particular night. So in true scientific form, if somebody asked me, do you know with 100% certainty that the lightning strike caused the crack in the first hull? No. But neither does anybody know with 100% certainty that it didn't either. And so you can't say, it's non-conclusive, really. What I do know is I had to replace all the electronics inside because of lightning.
The acoustic monitoring system was unique to Oceangate. Who built it, and what was its job?
I got to take us a little bit back on the acoustic monitoring being unique to Oceangate. The acoustic monitoring is just a suite of instruments that we called acoustic monitoring. It is part of what we used, but the idea of monitoring carbon fiber structures acoustically, that's been around for a long time. That is not new science, and we didn't pioneer it. We leveraged it, for sure. And in leveraging it, we also applied and installed strain gauges to measure movement. So ideally in acoustic or in carbon fiber structures, when they break or they crack, which they will, when put under tension or compression, any kind of load, you will get some breakage. Eventually it should stop. Will send off a noise, a pop. Sometimes it's loud and we can hear it, and sometimes you can't. It's the small ones that are in the millions, so to speak. So you want to count those because they could be meaningful. But not measuring how much a structure, in this case the hull, would move along with the acoustic noise is key. So it's not just acoustic monitoring that saved us on the first hull. The data that I was looking at was it's moving more than it should. It was moving close to and out of the tolerancing that we designed the titanium pieces around, and we should proceed with caution. In addition, it was making more noise than we thought it would, and that's why I canceled or did not let Stockton go to Titanic in 2019. And so really, that is what tells you the design of the system. The entire vehicle worked like it was supposed to. It gave me the data that I could interpret to prevent an accident.
We've now seen really alarming and heard really alarming evidence of this acoustic monitoring system. I mean, the noises when you hear it, tapping and banging, and Stockton himself, is pretty alarmed. Yeah. That's frightening to watch.
It is, yeah.
What is happening?
Yeah, there's glue is separating and fibers are breaking. It's just that simple, and it's loud. There's a lot of energy in that system. The loads are incredible. They are extremely high. I think my back of the envelope calculation, it was somewhere on the order of 150 million pounds of force at 4,000 or 4,500 meters. That's a lot. These are numbers that we don't throw around every day. Yeah. But when these structures give, it can be noisy. The thickness of the hull, it was 5 inches thick, and the size of it and how much material was in there, it wasn't known or expected that it would be that loud. We in fact had no idea. So hearing them was new to us, and what we were looking for with the acoustic monitoring was, do those events eventually taper? So it approaches a very low number, 0. In engineering terms, we call it asymptotically approaching 0. Never actually gets there, but it gets close.
What was your response when you heard those noises?
Wow. We first noticed or heard what the cracking would sound like when we tested small scales at University of Washington. We could hear them through the vessel that we were testing parts in, and those walls were pretty thick. And Stockton and I, we kind of looked at each other and thought, oh my God, that's louder than we thought it was going to be.
Was that data and the data in leading up to 2019, that was obviously pertinent in the scrapping of Titan 1?
The data that I observed in 2019 is what led me to force more testing, which prevented them from going to the Titanic in 2019, effectively canceling that trip. And while the crew was readying for that trip, a crack was found. And so up until that point, we didn't know it was there.
Was it your view? I mean, you've said, it's the sound of glue popping and fibers snapping. And to some extent, you expected that.
Mm-hmm. Yeah.
So I'm just trying to clarify, was it your view that the carbon fiber hull would and should delaminate, deteriorate to some extent over time, but that you would get a warning when it was too dangerous and then you would rehull? Was that the plan?
Right. Right. So let me take the last part of that first. If it was damaged enough, your question was, would we rehull? So scrap and rebuild. Yes and no. That's a bit of a problem, or was, because the titanium end rings and domes were a match set. It's a large challenge to make a hull to match the modulus of those pieces. And I have, for those watching that don't understand what a modulus is, it is really the way or how much a material moves. And so it's very important in these structures that need to maintain integrity together, is the moduli have to match. So they move together. If the titanium is one moduli and the carbon fiber is another moduli, then that's how you get a separation. And I talked a bit about this during the Coast Guard hearings. So that's very important to know, is that would be a bit of a challenge. In theory, it can be done. It's never been done, and until you actually get into it and take some measurements, do some analysis, and know what your predictive moduli needs to be and whether or not you can actually meet it, that still has yet to be done.
How can you say on one hand there was glue snapping, there was glue breaking, there was fiber snapping, the carbon fiber hull was making a lot of noise, it was delaminating, deteriorating to some extent, but that doesn't mean it was a failure?
So all materials, almost all materials, have some sort of flexibility, and they move. Skyscrapers move, airplane wings move, airplane fuselages and bodies move. But how do they move? And the way that they move to a material scientist, metallic structures, is, let's suppose that you have a picture of atoms, very, very small structures, very well lined up, and they're very orderly. And let's suppose on the bottom you have 10 rows. And on the top of some imaginary plane, someplace in space, you have 9. So you have one extra row in the bottom than you have in the top. And when that is stressed, doesn't matter which way you do that, when you stress that hole, it's called a discontinuity to a material scientist, moves. And it moves along all the rows. It goes from one place to the next row, to the next row, to the next row, to the next row. And when you keep moving it like this, they move all over the place. And eventually they move to the surface, and they pop out of the surface. I mean, this is something known at the atomic scale. We don't see it. You need really big microscopes and equipment to see this stuff. But it eventually pops out to the surface. When you don't have those holes to move around, we call that work hardened. This is very similar to everybody has taken, almost everybody I would say, has taken a paperclip and just kind of done this to a paperclip until it breaks, right? Well, when it breaks, all those discontinuities are gone. So you have no more flexibility in there. The material won't move, it fractures. So it needs those holes. In carbon fiber structures, well, let me back up. If you were to take a look at that movement with an instrument, you could say that a signature, whether it's light or noise, does get emitted when that happens. We just don't measure it. We don't measure it because metallics, solids, are so well characterized. We know so much about them. In carbon fiber structures, we don't, because every one is so different. So a design which calls for, let's just say a hull, a tube. Really, it's just a tube. That's it. It's a cylinder, 5-inch thick cylinder. If I gave that same design to 5 different companies that make carbon fiber cylinders, I might get 5 different products at the end.
Isn't that one of the key concerns, that that material is inconsistent and therefore unreliable at extreme pressure?
The inconsistency in a manufacturing process does not translate to reliability out in the field. The way that you control that is by using a process called witness panels. And so let's suppose that you wind a hull, you have some other pieces of it that go through all the processing, and you keep those and you test those. And those witness panels tell you a lot about that. Now let's suppose those 5 companies, their witness panels came out the same. You have the same product and the same thing. And it can be done. All I'm suggesting is that a carbon fiber structure build is heavily process dependent. It's independent of the design itself. And it's a possibility that it can come out a little bit different. Does not translate into reliability in the field.
Just to really simplify it for people watching, can you explain how that contradiction between saying it moves, it popped, it cracked, it was snapping, but we continued, but we thought that was okay? Right.
So where I was going with the lattice structure in solids, there are processes in solids where you harden the material or you quench the material. So you heat the material, stick it in an oven, and then you pour cold water over it or stick it in an oil bath. These are all processes to get the material to do what you want. Very good example of that in non-metallic structures is your windshield in your car. That heated glass is quenched on the outside, and that's how your windshield in the front can take the impact of a stone, but the window in the side does not. And it's because of that surface quenching on the outside of that glass. But that's just a process. In metallics, that process you can use to harden the material. You can use it to soften the material, make it do whatever you want. In carbon fiber structures, you can do that. So a way that it can be done is you take your vessel or your structure and you subject it to loads. You put it in another vessel and work all those out. You work all the cracks out, and it's going to move, and it's going to do that. It's got to realign itself. All materials do this. Just about all the materials. I have to be careful when I use the word all. Rubber bands might not do it. So there is a way to do that. For Oceangate in Stockton, chose to do it in the water and listen to the acoustics and collect that data. And Stockton wanted to be in the vessel and collect that data himself. In some respects, he almost kind of got to hand it to him. I mean, he went in himself. He didn't hire somebody to go do this for him. Almost like the dirty work. Hey, you go do this. Right? I'm the CEO. I'm gonna wait on top of the ship and wait till you come back. Nope. At the beginning, he wouldn't let anybody else go in with him. It was only him.
But then he started taking passengers.
He did. Yep. As he gained confidence and got closer to wanting to go to the Titanic, he wanted to take people with him.
Why did you refuse to pilot the Titanic missions?
Right, so I've heard I've heard some explanations out in the media, and I've read a lot on this, and a lot of folks are reporting what I've said, but stop short of maybe the entire statement. I didn't trust the operations crew. And I told Stockton
Wow.
that.
You didn't trust the Oceangate team?
The operations crew. The operations crew was led by a person that was well over his head. He really, in my opinion, didn't belong in that role. And I wasn't going to put my life in his hands.
You testified that you told Stockton you wouldn't get in the Titan. How can you build something that you refuse to get in?
He should have wondered that, in my opinion. So Stockton and I would talk a lot. Sometimes they weren't quiet talks. Maybe some of them were a little heated. They were definitely borderline argumentative. That he needed to change his operations crew. Eventually, he made a change in name, but not in role. No, he wasn't happy about that at all.
It's extraordinary to hear you say it, that you built this sub, but you didn't feel safe to get inside it yourself.
That's right. Yeah, but you have to qualify that with the reason. I mean, is it a technical reason, or is it a culture reason?
Mm-hmm.
And I'm saying it's the latter.
Would you say you were confident with the build, and you were confident with the engineering, and you were confident with the hull? You weren't concerned about those things?
No.
Despite the noises, the acoustic monitoring that we've now seen?
Yeah, those were
That didn't
expected.
concern you?
Those were expected. What we wanted to see was an attenuation or a reduction in the number of them, and we were starting to see that. The hull was built with a meaningful safety factor, and the data didn't concern me. The strain data didn't concern me. It was working like it was intended to work. As we went on, the movement started to approach borderline, and it was moving more than we wanted it to or thought it should. So it was eating into our margin, and that starts to raise your eyebrows. I expressed that to Stockton, wrote it in a report, and I said, here's something that we should keep our eyes on, and that is probably one of the few events where Stockton's and my relationship started to diverge. Our interests weren't matching anymore.
So just to be really clear on that, did you leave Oceangate because of your concerns about the hull and the sub diving to the Titanic, or did you leave because of the culture and the team that was sending it down there?
If I could answer that in kind of parts. 2 years into my stint with Oceangate, I was looking at opportunities to leave because of the culture. It became evident to me that if I left, the technical direction would be directionless, and I couldn't. If something happened to folks, and it's because it was directionless, that would be very difficult for me to sleep with. So I stayed. And what I then realized is I'm going to have to keep pushing and controlling what I can until I get fired, which eventually happened because I wouldn't buy off on serial number 1.
Serial number 2, which I believe was being commissioned when you left, when it came to a head. What was different about that hull, and what were your concerns about it?
I don't know what was different. I know what should have been done in order for it to meet the same performance, and whether or not that was done, I would imagine that's part of the investigation. I hope it was.
Yeah, But hull one was cracked. They had to rebuild. You expressed your concerns to Stockton and he didn't take it well.
No. Yeah, no. And you know, I've seen, it's now out in public record, pictures of some things that they did different to the vehicle that I expressly told them that you cannot. And in my opinion, the reason why I told them you can't is it'll lead to a failure.
Such as?
The lifting eyes that were put on the ring that I testified to, 100% could not do that. That's because the center of gravity, and for maybe folks that don't know what a center of gravity is, but it's really if I were to take all the weight of, in simple terms, all of the weight and bring it to one point so that it's really balanced on maybe a pin, that would be the center of gravity. Typically, you want those in the center of a structure, but it was not the case with the vehicle. So when it lifts cantered or angled, and that then puts stresses that the titanium rings were not designed to hold. And then the pictures, the real disappointing pictures, were the pictures that I've seen out there that they left it in the Northeast during the winter. That was an absolute no. So I testified about this. The issue with lifting it on an angle, if there's a peeling action to the lip, which I am very certain this would have happened. You get water that creeps into the titanium clevis, which looks like a C, and the carbon fiber piece that is glued in there then gets water in between, and if you sit it outside in the freezing cold, that water expands and separates the structures.
How do you say the system worked? Everything was as we expected, but I wouldn't get in the sub, and it wasn't safe to go to that depth. How can those two things be true?
I wouldn't go dive in the sub because I didn't trust the crew and the culture topside. Whether or not it was safe to go in there, the acoustic monitoring and the feedback that we had, the instrumentation on there, the strain gauges, how my team programmed it for serial number 1, it was great. We had nice visuals that told us how many pops we were hearing, what was the accumulation, what each instrument was doing, how much it was moving. Like everything looked great from a technical perspective. Everything looked great. There wasn't anything that I could say that you need to stop this now. It didn't come to that until after we finished qual in December of 2018, I think it was, and Stockton wanted me to sign off so that he can go to the Titanic, and I analyzed the data, like everything that I had, for about a month, and I came to the conclusion that we may not know what it's supposed to look like, but it shouldn't look like that. There was conflicting data that said you might want to do something more, and that's what I pushed for. Like, we needed more testing. The system told me that's what you need to do. That's where you need to go. If I didn't have that on there, or I had anything less than we had built inside, we wouldn't have seen that.
So you knew at that point the risk was too great.
Yep. Yeah, I told him you can't take passengers in there that have this expectation that it's good to go.
And what was his response?
Oh, he was not happy. I actually, it was such a tumultuous time and day. I remember the meeting, and I got to tell you, I almost feel like I blacked out for the rest of the day. Like, what is going on? Like, there is so much of that day that I don't remember. He was not happy. None of the crew was happy. I was the only person that was standing between them and going to the Titanic in 2019.
It's become clear there were so many people in Oceangate who knew about the safety issues that were not being resolved. Why could no one stop Stockton?
Well, we could go over, and it might be a good idea to take a look at what some of those safety concerns were. Just because it's value added for somebody to bring up a safety concern, for sure. Then we take a look at it and say, is there technical merit to the safety concern? Is it technical or is it operational? And can we do something about it? And should we do something about it? Like, maybe somebody doesn't feel like something is maybe good to go, and they're not comfortable with it, and they're expressing their discomfort in that way. And maybe it's flat out a no-go. We cannot go with this concern still an issue. These are risk assessments that must be done. During my tenure there, safety concerns that were brought up of the technical nature, all of them were addressed. Safety concerns that were brought up of an operational nature, I don't know.
In your simplest words, what could have stopped this?
They shouldn't have fired me. Like, we built a system that did exactly what they ordered and prevented this tragedy from happening a few years earlier. And we were brave enough to do so. And it worked. It 100% worked. And I think, and that's not being addressed anywhere. For someone to say that it was inappropriate or was a bad material or the system didn't work, that's great as an opinion, but take a look at the data sheet and tell me what you see. Like, can you interpret the data? And do you understand what that means? These aren't statements that should be made lightly at all.
It is a mathematical certainty that if you keep diving to the same depth in a weakening hull, it will fail.
It's a mathematical certainty that if you don't put gas in your car, you will run out of fuel. True. It's a mathematical certainty that there is going to be another airplane crash, killing all on board. Not true. It'll probably happen, right? We all know that it's still a risky proposition to go do that. But unless you give it bounds, you can't know that. Weakening, sure, that sounds like a bad thing. What if it stops weakening at some point? That is fine. That was never in the comment. It was a very short-sighted, knee-jerk reaction, and it was completely non-technical. With 100% certainty, if anything degrades and does not stop degradation, sure, more than likely it'll become unusable. Yeah. And do we call that the failure? Yes, maybe so. And at the point for a submersible, at the point that submersible becomes unusable, that is okay to call that a failure. Like, it's done. The hull's failed. Does it have to implode and kill all on board to qualify as a failure? No.
What are the odds that the hull, if it's weakening, will at some point stop weakening?
That's kind of the open-ended question, and we wanted to see. Ideally, yes, in a carbon fiber structure, you will load it to a point where all the fibers that are loaded to the point of failure break, and then there's no more breaks to happen. Yes, it can do that.
Is that a possibility?
100%.
So just say that for me again, because I think that blows my mind. I feel like I hear the hull screaming and the bangs, and I think it's weakening, it's snapping. This can only go one way. So just explain that again. You're saying actually it can stop weakening and deteriorating and be fine.
Yeah, because it's snapping the weakest first. It's getting rid of maybe maybe those areas that don't have needed adhesion or full adhesion. No, it's a possibility. The thing with the carbon fiber structure, unlike a metallic structure, is once that snap happens, it doesn't bring itself back together. It stays separated. There's no more noise that can happen from that. A metallic structure, like we talked about, where the atoms line up, once it moves to the next row, it keeps going until it goes to the surface. At that point, you have no more sound or light emission, whatever gets emitted when that hole or that discontinuity pops out of the surface. It's the exact same thing. We just don't talk about it in those terms. But a carbon fiber structure, once that fiber breaks, it's done. So the idea is that if you reduce the amount of noise and the number of occurrences, and your structure doesn't move past a certain point anymore, so you have no noise, no additional noise. Let's suppose this is a great. Engineers have to do this. Scientists really a thought experiment. You have to take it to the extreme and see if it makes sense. So let's take this one to the extreme. It's a perfect structure, and after we load it for a little bit, it goes to zero noise. Okay, so we have a big zero, nothing, no acoustics or anything, and the movement inside stays well within your tolerancing. That structure is not going to fail. It's stopped. It's seasoned. And seasons, it's a strange word to say for materials because we season our cast iron skillets. But it's seasoning the whole, so to speak. It's getting rid of all the weak links, and what should be left is what is strong. And I say should, because the scientists should say should, until we get a lot more certainty, or I know for certain. But that's the reason for monitoring it, and that is not new science.
Did you ever get that certainty while you were at Oceangate?
No, that's why I stopped 2019 and said you need more testing. And the phrase that I use is because we're the first to do that. Is we may not know what it will look like in the end, but it should not look like that.
With everything that you know and that you saw, was the implosion inevitable?
No, 100% avoidable. 100% avoidable. We did it in 2019, and the data that I saw during the Coast Guard investigation, it should have stopped. They had the data in front of them.
There are clearly a lot of people on the board and in the company who presumably knew about that data.
I find it difficult, quite honestly, to think that one person controlled whether or not the sub would continue on, even some of the problems that I had with Stockton. The thing with Stockton is, if I talked very technical to him, and I gave him very, very good reasoning, sometimes I would say he would accept without a fight. Most of the time, he would accept with a fight. Sometimes, sure, he wouldn't accept at all. If I didn't let up and it was important enough, I suppose I could get the proverbial saying, I can get what I want or what I needed. So for the data to be so clear, and to hear Phil Brooks testify that I didn't know how to interpret that, there's your failure. That is not a technical reason that it failed. That is a cultural and a staff reason.
There is the scarce remains of a submersible at the bottom of the ocean with 5 people dead. And yet, you believe the issues weren't technical. It was operational and cultural.
That's right. They weren't technical. We saw the data. And until I saw that at the Coast Guard hearing, I wondered. I wondered for what's it been, a couple of years?
You wondered about the engineering aspects of Hull 2?
What went wrong? And I would have to say, that because Hull 1 took a lightning strike, it's inconclusive, really. I know that even with the lightning strike, we still achieved 4,000 meters. We broke 4,000 meters, and we did, a few dives without a catastrophic failure, and we had the data to stop it. How I was always confused at how that didn't happen with hull number 2, and I thought something had to have gone seriously wrong.
And what was that fatal flaw to your mind?
I have to say we, but I'm really saying anyone with maybe technical know-how has to be very careful about how we communicate, whether or not it's the material choice, the shape, the structure, the processing, the components used. All those are possibilities. It doesn't do us any good for non-technical folks to broadcast themselves on TV that it was a material choice. It's not helpful whatsoever. So when hull number 2 went, and I was deposed by the Coast Guard and the NTSB early on, and we had the conversation that about water seepage and the lifting eyes. Like when I started seeing that, if you can believe, it wasn't too long. Well, the morning that the implosion happened, my phone just blew up. I didn't know what could have happened that makes my phone ring at all, but it did, and the messages and pictures started coming through, and a few that I knew and worked with at Oceangate would ask me questions like, were these supposed to be on there? And they showed me pictures on CNN of the top view of the submersible, and there's lifting eyes on it, and so at that point I started thinking, like that's not supposed to be there, and in my brain it didn't stop. I'm wondering what could have gone wrong, and that's not a technical problem. That's to have that on there when the person who designed the ring said you can't, and I find it on there. That's cultural.
That was a bad decision.
That was a bad choice. And I know, and I know they did it when I wasn't there because I turned it down. The same person who I've referred to as, in over his head as the director of operations at the time, and I didn't trust, wanted those lifting eyes on there, and I told him no. Our models and analysis said it's not a good idea. But that's an example of the concerns that would come and we would put to bed. So the idea came to me, we want lifting eyes on there. We went and did finite element analyses, much the same way that you would do model aircraft. And we took a look at where the stress concentrations, and is this a good idea? Didn't pass.
So with everything that you know and what you've now seen, you've seen the vision of the wreckage, you've seen photos of it, before it went down, you've sat through those hearings. Did the hull fail?
No, I don't think so. And it was said as plain as day during the hearings. And when Tim Catterson described what he saw when the first pieces came overboard, that were recovered and came overboard onto the recovery ship, the first pieces that he described of the forward ring was exactly what I had told the Coast Guard and the NTSB would happen if water seepage froze in between the hull and the clevis being the titanium piece. It 100% matched that.
Explain it to me for the first time in a succinct way. What caused that implosion?
There's a couple of possibilities, and so we do have to talk about at least these two. One, the modulus of the hull was not matched to the titanium rings. and they did not move together. And if they did not move together, our models that we produced to build serial number 1 showed that it would fail. And it would fail in the location that it did. And so that's a possibility. The other possibility is that there was a separation at the titanium carbon fiber glued interface in the forward clevis, and it would allow the hull to move and push against, if I can show you a shape of a clevis, these pieces right here were actually really short. They were very small. They weren't really needed very much. It held glue, and it kind of held the ring on there. Gave it a little bit of integrity, but really there was so much pressure coming, in engineering terms, we say axially, so along the length of the hull. There was so much pressure squeezing on it, you almost didn't need those at all. There's a point where in subsea, two structures pushing together won't separate anymore. There's so much pressure and load pushing them together, and so that would have been felt. If that glued interface of the clevis and tang is not there anymore, that can skip, and it will peel the inside part of the lip of the clevis in, so this will rip, so to speak, and it'll collapse itself. If it was solely the hull and nothing else, as in an unprofessional way, I'll say talking bobbleheads or saying, if it was the hull and that's all we hear about, that's it would have crushed in the center. That ring that came out, and Tim Catterson described it during the Coast Guard hearings, that's not the center. That ripped at the forward ring first. Because if the pressure is relieved in the center, the forward ring wouldn't rip like that. And in fact, you'd probably still have carbon fiber stuck to it.
Those two possibilities you just talked through, were they engineering, design decisions that were made after your time?
The first one, let's talk about whether or not the modulus matched. So I don't know what happened with that. Maybe they attempted to. Maybe they didn't. That I don't know. That would be a very good question. And where's the analysis that you did? What I told Stockton and the next director of engineering, Dan, what I told him that you need to do, because it was a match set, if you plan on using it, there's no other option than when you cut the carbon fiber out of the clevis of the titanium piece, you are going to shave some of the metal away from there. You are going to make it thinner. You have to redimensionalize those. So you have to take measurements, and you have to put those measurements in the computer model, and you have to do what's called a finite element analysis, an FEA, which will tell you how it's going to break. And it's going to tell you how it's going to move, what the modulus would be. That number then has to be met in the hull itself. And so whoever wound the second hull, if they weren't given direction to meet a modulus and didn't have a way of verifying that with witness panels, you wouldn't know. There is no way of knowing. And so that's option number one. Number two, the couple of ways you can get water in there. Well, I'll say there's only one way. The glued interface at the clevis and tang, and the tang being the carbon fiber structure and the clevis being the titanium, again, to get water inside there, you have to compromise the glue that is there. There's no other way to get water in there. And there's a barrier, a coating should have been on the outside. We did do it on serial number one. I'm assuming they did on number two. I have to assume that. The only way water is going to get in there if that glue is compromised. Once water gets in there, There is no way of knowing that. And that's why it couldn't stay in freezing conditions. It always had to stay above freezing of water.
Based on the data that you saw in testing, was that hull weakening with every dive?
So when I wrote the report that it was flexing too much, there's only two ways that could happen that needed to be investigated. And I believe that is in my report with the Coast Guard. One, we have to know, did we really have the modulus correct? And two, do we have more separations such that it's now moving too much? And so when it started approaching, there was a really finite window. It couldn't, this is gonna sound a little strange, but it had to move within a certain range. It had to. So the idea that, well, if it doesn't move, it's not gonna break. And that's not true. That's that modulus question, because the titanium is moving. And so the hull had to move with the titanium at the ends. Absolutely had to happen. So what I saw was movement that was approaching our limits. And it was more than we expected, and that required some investigation. It would, like some caution, really.
It sounds to me like the Coast Guard will hand down the report in, the coming days, if not next couple of weeks. Do you believe anyone should be held accountable?
Oh, yeah, absolutely, personally. Yeah, even professionally, I do. Like professionally, I wish that we would really talk about what went wrong in a technical sense. And if we can't find the technical reason, then let's take a look at the cultural reason. And if the cultural reason is there, then let's call it the cultural reason. But the answer for that, yes, I'm very interested for just humanity to have the right answer in the future of exploration anywhere, not just deep sea. But then the idea that folks can do whatever they want and hide behind either a corporation or I didn't know, or fire the team that was the right team, and I think those are answers that should be evaluated. I mean, it would be a great discussion to talk about what if the engineering team I built wasn't taken apart. Would number two have imploded? I would say no.
2 years on, Tony, how do you reflect? Is it, do you have regrets? Do you have guilt? Do you have anger? How's it sitting with you after 2 years?
It bothers me a lot that the systems in place to prevent this were there, and it took more than one person to break them. And so what do I mean by that, really? It's not just, Stockton coming up with, you're out of here. And maybe that's what he wanted, so that he got an easier, better answer by somebody else. That's a possibility. The reason for my firing came from Stockton, if he was telling me the truth, 2 members of the board. But you got to wonder, if I'm the person that used the equipment that was designed to tell you that there may be a failure, and in fact saw that failure and prevented a catastrophic event, if you're a board member, why would you want to get rid of that person? And if you're the human resources person, how would you let that happen too? And if you're the chief operating officer, how do you let that happen? A lot had to go wrong. I mean, it's a systemic failure. And what bothers me is that, I keep hearing it's carbon fiber. That's the problem. With no technical backing whatsoever. I mean, James Cameron should stick to making movies. He's no more a scientist than I am a movie producer just because I have a GoPro. That's 100% certainty, for sure. So stuff like that bothers me, and the fact that the media gives them any kind of time whatsoever without challenging. Well, how do you know that? Like, what's your technical expertise? Like, just explain that to me. Willing to bet that neither James Cameron or Rob McCallum can explain in basic material science terms what I talked about here today with the differences between metallic structures, glass structures, and carbon fiber structures. They're not engineers, yet they have a lot of media time saying it was the carbon fiber. And that's the conversation that we go down. Maybe it was, right? Maybe it was. What I'm saying is we can't say that that's what caused this failure. Like maybe it would have failed eventually in the center of the case, which would have been more of a carbon fiber issue. And then we'd have a different conversation, but that isn't the case. And in fact, the small scale tests and serial number 1 showed that wasn't gonna happen either. So that bothers me, that I keep hearing that, and I don't have an outlet to go defend that. And there's less conversation on the culture. I testified to the Coast Guard that it wasn't a technical issue, and it wasn't a regulation issue that caused this accident. It was a cultural issue, and they didn't ask me another question about it. Not at all.
Why is it important for you to set the record straight?
Because I don't want stuff like this to stop. Because we were successful. And if somebody looks at this and says, you got to pile a whole bunch of regulation on them, and maybe so. Like, regulation is put there to control bad behavior. But were we acting badly? Technically. And from a design perspective, was it? No. No, it really wasn't. It was serial number 1, and really some of the parts that were used in serial number 2 were designed the way aircraft is designed. In the same way.
I guess you can't get past, at the end of the day, the proof is the ultimate catastrophe. It failed.
That's right, and it's tragic. And sitting, I got to tell you, it really did. Even though I wasn't part of serial number 2, for the Coast Guard deposition, some of the family members of those lost were there. It's heartbreaking to know what they've lost. It really is. Under any circumstances, it would be. But I don't want this stuff to stop. I want the correct cause and corrective action to be implemented. It's very much an engineering thing to do. Find the right cause, and do the right action for the cause. Once regulation can figure out how to regulate culture, then we might get someplace. But it's failed to do that in every instance. We just lost another airplane. Was that design? Or was it? If it's design, then you kind of got to shut Boeing down a little bit. Another thing that bothers me is, 240 people recently perished on the plane leaving India. But that's okay. Like, it's okay because what we've done is we've taken statistics and we said, your chances of dying in an airplane are actually pretty small compared to the number of aircraft out there and the number of miles that it's flying. And I've seen this twisted in so many ways. What I hear when I hear that is, if I would have built more subs, this wouldn't be a problem. Because we're diluting the loss. It's 5 people. We would dilute the loss in the number of subs that we have. Like, what if we had 1,000 losing 5? Is that okay? I mean, it's a weird question to entertain.